Yes, good afternoon, students. Okay, so I hope all are doing good. Yes, so after a long time we have met, so I can see some of the students who were already enrolled during our PU1 CET classes. Right, so I hope everyone over here who is present have written their PU1 exams very nicely. Yes, good. Yes, so you have entered into PU2, right? So you have you're going to uh, you are going to PU2 now. Yes, so you have your classes are starting from today, right? So already you might have attended maths and bio class, right? So this is the third class. I hope your lunch is over. Yes, so don't be sleepy now. You're active. Everyone is active. Yes. So ready. So the for the chemistry, right? So we are going to start with the first topic. So are you all ready to see or you to study the topics, new topics over here? Yes. Yes. Okay. Good. So yes, as you all know, okay, some of the students are new over here. I would like to introduce myself. My name is Richa Patil, and I am going to teach you all chemistry for this academic year. Okay, so as some of the students might be knowing me, okay, some are new, so I can see you are nearly 19 participants. Okay, so yes, so the first topic which we are going to start is solution. Okay, so whenever whenever the class is going on, okay, so if you have any doubts during the session, please ask it in the chat box. Okay, you can ask there any point. Okay, anytime you can stop me there and you can ask your doubts. So don't be shy. Okay, don't be shy. So whatever uh okay, so whatever the doubts are, you can ask there and there itself. Fine. And if whenever we are telling anything, so please note, okay, take a notebook and a pencil or a pen and note some of the important points. Okay, so this will help you for your competitive exam. So whatever formulas, okay, whatever we I'll be telling, so you please note it down so that if it is very important, okay, so that it will help you in the competitive exams. Okay, so we'll tell you there and there itself what is important. Okay, so that you will be more focused on that. Okay, fine. So going to the topic, so the first topic which we are going to start is solutions. Okay, yes, so in our day-to-day life, okay, in our day-to-day life we see pure substances, right? We see pure substances. So rarely we come across the pure substances. There are only few pure substances. Okay, but you can see that most of the substances, they are in the form of mixtures, right? They are in the form of what? Mixtures. Now what are these mixtures? Yes, students, what are these mixtures? You might have studied. We have already studied in our PU1, okay, in the PU1 section about pure substances. What are mixtures? Can you tell me what is mixture? Yes, what do you mean by mixtures? Okay, Suraya has answered as homogeneous mixture. You're telling about the types of mixture. Okay, I'm asking you the definition. I want the definition of mixture. Mixture is a substance. Okay. Okay, let me tell you. Okay, so mixture, yes, it is a substance which is made up of two or more. Yes, it is a combination of two or more substances. Okay, understood. Yes, Ananya. Yes, Anita has also answered it. Yes, so mixture is a substance which is a combination of two or more pure substances. Now, in our day-to-day life, okay, when we are studying about a particular solution, Okay, it depends on what? It depends upon the composition. Now, for example, the alloys. Now, what are alloys? Do you know what are alloys, students? What do you mean by alloy? What do you mean by alloy? Did you come across this term called alloy? Mixture of metals. Okay, fine. So brass, is it a alloy? Yes. Brass, is it a alloy? Yes. Okay, good. Yes. So brass is a alloy. Okay. So brass is also what? It is made up of, it is a mixture. Okay. It is a homogeneous mixture of copper and zinc. It is made up of what? Copper and zinc. Okay. So there's one more called as German silver. Okay. German silver. So this German silver, it is also made up of copper, zinc, and nickel. Okay. And one more alloy, bronze. Bronze is made up of what? Bronze is made up of copper and tin. So these are what? So these are all mixtures. Okay, what we are studying is these are all mixtures. So there's the composition is not similar in all. So when we are talking about solutions also, so in everyday life, when we are discussing about solutions, so this solution, it depends upon the composition. Okay, it depends upon the composition. Okay, so now what is this solution? Yes, students, what is this solution? So solution, it is a homogeneous mixture of two or more components. Now, what do you mean by homogeneous mixture? Yes, homogeneous mixture means what? Homogeneous mixture. Okay, can I give you example? Sugar and water. Is it a homogeneous mixture?
Yes, ma'am.
Yes, sugar and water is a homogeneous mixture. Salt and water is also a homogeneous mixture. Okay, so when we are adding sugar to the water. So when you stir it, okay, can you see any boundary or can you see any separation? No, the sugar gets dissolved in water. Okay, the sugar gets dissolved in water. So it is a homogeneous mixture. So uniformly, okay, uniformly it gets distributed. It gets distributed. Okay, so no boundaries are seen. So it is called as homogeneous mixture. So solution is a homogeneous mixture, okay, of two or more components. Okay, and it is made up of two terms. Okay, one is solute and solvent. So when we are studying about solutions, so we are going to study some of the terms now. Okay, we are entering into a chapter wherein we need to introduce ourselves, okay, to some of the terms now, right? When we are entering into a function, okay, we have to first, you are going to directly go and meet the groom and bride, or first you're going to meet the relatives. Yes, so we are going to meet first the terms. Okay, now when we are entering into the topic, first we are going to meet some of the terms now. Okay, we are going to get introduce ourselves to some of the terms. Okay, so these terms will help us to understand the concept more clearly. Okay, now what is this solute? Okay, okay, what is this solute, students? Solute, okay, it is a component which is present in smaller quantity. Okay, when we are discussing about solute and solvent, okay, you can see the picture down. Yes, you can see your picture. So what we have done here, students? So we have taken a beaker. Okay, we have taken a beaker. Into this beaker, we have added water. Okay, we have taken water. Now, what is this water? Okay, I'll take this water is called as a solvent. Now, whenever we take water, okay, now water will be in larger quantity, right? Water will be in larger quantity. Now, when you're making tea, okay, when you're making tea, okay, what water will be in larger quantity, right? To that, you're going to add your tea powder and sugar, right? Now, here, when we are taking a beaker, when we are taking this water, so water is a solvent. What is this solvent? So the component which is present in largest quantity. Okay, the component which is present in largest quantity is called as solvent. What it determines? It determines the physical state of a solution. What it determines? It determines the physical state of the solution. Now, when we are discussing about the physical state, okay, you know, mainly we have studied about solid, liquid, and gaseous. Okay, solid means what? The molecules are closely packed. Okay, liquid, the molecules are densely packed. Okay, and in gaseous state, they are free. Okay, the molecules are free. Right. So this is a in simple terms. I'm been telling you. Okay. Now these are the physical state. So component is what? It is present in largest quantity. Okay, that is your solvent. Now, what is the solute? Okay, you can see here the purple color, right? So this is a solute. Suppose when we are adding sugar, okay, and tea powder, what is this? This is nothing but your solute. So when we are adding solute to the solvent. Now, when we are adding sugar, okay, suppose we are adding sugar to the what beaker containing water. Will you take same amount of sugar? No. When we are making tea, okay, for 1 glass of tea, we'll add 2 spoons of sugar. Only 2 spoons. We are not going to add 1 glass of sugar, right? So here the solute is present in what? It is present in smaller quantity. It is present in what? Smaller quantity. So our solute will be present in smaller quantity. Okay. So we have discussed 3 terms till now. What is homogeneous mixture, what is a solvent, and what is a solute. Okay. So if you so whenever I ask you, okay, you should be ready to tell me, okay, what is solute, what is solvent, and what is homogeneous mixture. Are these 3 terms clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So so these are the 3 terms which we have discussed: homogeneous mixture, solvent, and solute. Okay. Now, the next what we are going to discuss is a binary solution. Okay. Next is a binary solution. So what do you mean by binary solution? Binary. Okay. Binary means 2 components, right? Binary means 2 components. Okay. So binary solution. So it is composed of 2 components. Okay. There can be, now you know this binary. So there are, if ternary, what do you mean by ternary? Ternary means it composed of 3 components. Okay. There is some other, okay, if you have 4 components, then it is called as quaternary. Okay. Now we are discussing only about the 2 component solution. Okay. So what is binary solution? So the solution which consists of 2 components, then they are called as a binary solutions. Okay. So you can see this. Okay. So these are the main terms which we are discussing in this chapter. Okay. Now, as we know, when we are discussing, so solvent. Okay. Solvent, what it determines? It will determine the physical state of a solution, whether the given solution will turn into solid, liquid. Okay. So it depends on the solvent. Okay. So solvent is what? It determines the physical state in which the solution will exist. So you can see here, we have taken a beaker. Okay. There is a solvent which is present in larger quantity, and there is a solute which is present in smaller quantity. So when we add the solute to the solvent and when we stir it, you can see this is the solution which we obtain. Okay. So these are the basic terms when we are studying into solution. So next we are going to study is types of solution. Next, what we are going to study? Next, we are going to study is types of solution. So depending upon the phase of solvent, okay, depending upon the phase of solvent means what? Whether the solvent is present in solid, liquid, or gaseous. Okay, so these binary solution, it is classified as follows. You can see here, yes, you can see the chart.
Yes, ma'am.
Solution, yes. So this is a chart, okay, wherein you can see how the binary solution is classified. As we have discussed, so we have seen, right? What was that? So solvent will decide, okay, solvent will decide what will be the what physical state. So solvent will decide the physical state. So here we are going to see which are the different phases of solvent. So when the solvent is a gas, when the solvent is a liquid, when a solvent is a solid. Okay. What are the different types of solution? So first is the gaseous solution. First is what? Gaseous solution. So in the gaseous solution, we have solute and solvent. Now you know what is solute? Solute is present in smaller quantity. What is solvent? Solvent is present in larger quantity. Now here, solute. Okay, solute is a gas. We have taken solute as a gas. Okay, and the solvent is also a gas. So what is the example? Mixture of oxygen and nitrogen. Okay, O2 gas, diatomic oxygen, right? Diatomic. What do you mean by diatomic? O2. O2 is a molecule, right? O2 is a molecule. How this O2 molecule is made up of? When two atoms of oxygen combine. Okay, you get a O2. So it is a mixture of O2 and N2. Okay, N2 is a N2. Okay, so these are the mixture of O2 and N2 molecules. Okay, so this is a gaseous solution. So please remember the example. Okay. Uh, yes. Can you hear me now?
Yes, ma'am.
Yes, ma'am.
Okay, okay, sorry. Fine. So we were discussing about the gaseous solutions. So gaseous solution. Okay, so the solute here is gas and solvent is also gas. So the example which we are discussing is mixture of O2 and N2. Now, when the solute is a liquid, okay, and the solvent is the gas, so chloroform. So chloroform is what? Chloroform is a liquid. Okay, chloroform is a organic solvent. So that is CHCl3. Okay, CHCl3 is a chloroform. So chloroform, when it is mixed with N2 gas, okay, that is with nitrogen gas. Nitrogen is what? Nitrogen is a gas and chloroform is a liquid. So here the solute which we have taken is a chloroform and the solvent which we have taken is a gas. So this is an example of liquid in gas. Okay, liquid in gas, that is chloroform when it is mixed with N2 gas. So this is a type of gaseous solution. Okay, why it results into gaseous solutions? Yes, students, we have taken solute as liquid and solvent is gas. And why the result is a gaseous solution? Yes. Did you understand? See, first case, solute was a gas, solvent is also a gas. Okay, so it is a type of a gaseous solution. Fine. Now in second case, solute is a liquid and solvent is a gas. Why it is termed into gaseous solution? Yes. Already it has been told, you have to apply now. Okay, the things are told for you, just apply. I want to know whether you have understood or no. Why this is coming under gaseous solution? Yes, students? No idea? Yes, good. Yamuna Gowda has answered it right. Yes, good. Because solvent, yes, Ananya has also answered it. Good. Because solvent is deciding here, right? The physical factor, right? Yes. So physical state is decided by the solvent. So we have termed these examples under gaseous solution. Understood? Yes. Fine. So next example is solid. Okay, the solute is solid and the solvent is a gas. So what is the example? Camphor. Okay. Camphor means what? Karpur. Right?
Karpura.
Yes, Karpur. Okay, so camphor, okay, it is in solid state, okay, and a gas. Gas is your nitrogen. So camphor, so solute is a camphor, and your solvent is a nitrogen gas. So these are the types. So please remember. So for your CET exams and all, okay. So a type of so they can ask you give an example for solid in gas. Okay, solid that is solute solid and or solid in gas. So you have to remember the examples are very important. That is camphor in nitrogen gas like this. So these examples are very important. So please remember the examples also when we are discussing. Okay, next type of binary solution is next classification is liquid solution. Why liquid solution? Because our solvent is liquid, because the deciding factor is solvent, because the solvent tells you the physical state. So the liquid is all the solvent and your solute first one is gas. Okay, gas. So what is example? Oxygen when it is dissolved in water. Okay, oxygen when it is dissolved in water. So this is an example of a liquid solution. Then liquid in liquid. That is ethanol. What is ethanol? C2H5OH. It is a alcohol. Okay, it comes under the alcohol. So ethanol. So ethanol, that is C2H5OH. Ethanol when it is dissolved in water. So this is an example of liquid solutions. Okay, this is an example of liquid solutions. Next example is solid and liquid. So your solute is a solid and your solvent is a liquid. Okay, so the solid taken is glucose. What is glucose? C6H12O6. What is this glucose? It comes under which class? Yes, it is an organic compound. It is an organic compound. It comes under what? It comes under carbohydrates, right? It comes under carbohydrates. Okay, it is a sugar. It comes under sugars. So liquid solution, solute is taken as solid and your solvent is liquid. So the example is glucose when dissolved in water is the example for liquid solutions. Yes, Akshaya has answered it. It comes under carbohydrates and sugar. Yes, good. Okay, so liquid solutions, that is solid in liquid. Fine. Glucose dissolved in water is an example of liquid solutions. Yes. Okay. Next type. Next classification is solid solutions. Okay. Next is solid solution. So what is happening here? Our solvent is solid. Okay. Our solvent is solid. And this first one, the solute taken is gas. So when gas is the solute and solid is the solvent, that is solid. Okay. Then the example is solution of H2 and palladium. Palladium is a metal. Okay. Palladium. So solution of H2 and palladium. So this is what type of agent? This is used as a reducing agent. This is used as a reducing agent. So in most of the, in last year, you have studied hydrocarbon chapter, right? So H2, when you take H2 and when you take palladium, okay, so this is a hydrogenation. This is a hydrogenation reaction, right? So we are adding hydrogen. So this is a solution of H2 and palladium. Next example is liquid. So when your solute is a liquid and your solvent is a solute, it is amalgam of Hg with Na, that is sodium amalgam. Okay, sodium amalgam. So this is a liquid in solid. So your amalgam, that is mercury. Okay, mercury is present in liquid state. You know that. Okay, mercury is present in liquid state and sodium is a solid. Okay, so this is example of solid solution. Next is what? Solid. So solid solute, solid is alloy, right? We know that alloys are made up of metals. Okay, so all the alloys like brass, bronze, okay, gold, copper. So these are all alloys, that is solid in solid. So these are the classification of binary solutions. Okay, so according to the phase of solvent, so these are the three classification. So in this chapter, we are only going to discuss about the liquid solution. So here in this chapter, what we are going to discuss? We are going to discuss about the liquid solutions, that is the binary mixtures, okay, or that is of liquid solution with, okay. So next, so just a simple for your understanding. Please mute yourself. Whenever it is necessary, you can unmute, okay. It will be a disturbance. Yes, if you have any doubts or anything you have to answer, so that time you can unmute yourself. Okay, thank you. So gaseous solution. Okay, as we have discussed about the gaseous solution in the previous slide here. Okay, firstly, so gaseous solutions are what? Just for your understanding, here the solvent is your gas. Okay, and small amount of one gas are dissolved in a larger amount of gas. So when for example, air. What does air composed of? Air composed of different components like nitrogen. So nitrogen is present in 78%. Oxygen is present 20%, and the other gases also present. So what is a solvent is a gas here. Okay, so gaseous solutions. What are gaseous solutions? So gaseous solutions, here the main factor is solvent. So solvent is a gas. So just a brief idea. So as we know that we are going to discuss only about the liquid solution. So we have discussed the main terms. What are homogeneous mixture? Okay, we have discussed about what is solute, what is solvent, what are binary mixtures, and what are the types of solutions. Okay, we have discussed about the solid solutions, liquid solutions, and gaseous solution. So next we are going to discuss about the terms. Okay, concentration terms. Okay, so the concentration, the composition of solution. So as we know the solutions, okay, as we are discussing about the solution chapter, so the liquid, okay, the solution is nothing but it is made up of liquid. So the liquid is not present in the same composition, right? So this composition of solution, it should be determined, or okay, it should be defined in some way. So how it is defined? Okay, it is defined in terms of concentration. So it tells you about concentration. So there are several ways, okay, in which we can define the concentration of a solution. So we are going to discuss 1, 2, 3, 4, 5, 6, 7. So 7 concentration units we are going to discuss. Okay, so there are different concentration terms which we are going to use for expressing the solution, composition of solution. So the first is mass percentage. What is the first one? The first is the mass percentage. Now, what is mass percentage? Okay, the mass percentage of a component, it can be calculated by mass of the component in the solution divided by total mass of the solution into 100. Okay, so you can remember mass of solute. Okay, mass of solute, how much mass of solute you are taking and how much the total mass of the solution. What is solution, by the way? Yes, what is solution? Solution is made up of? What is solution?
Mixture of two or more components.
Yes, solvent, right? So it is made up of your solute and solvent. So we are going to take the total solution. So how the solution is made, we have seen in the, here you can see. See here. What is solution? When solute and solvent is added, we get a solution. So what is the total? Here you can see, right? Here in the diagram itself, you can understand. So solute plus solvent gives you a solution, right? So please remember these terms. Okay, don't get confused between solute, solvent, and solution. Now, so when we are deciding the mass percentage, okay, so it is given by W by W. It is given by what? W by W. So mass percentage of a component, it is expressed as mass of solute, okay, mass of solute divided by total mass of solution. Total mass of solution means it is comprising of both solute and solvent into 100. Okay. So what is the definition of mass percentage? Amount of solute, okay, in grams. So here the amount of solute will be in grams, okay, present in 100 grams of solution, because we are taking the mass. Mass is expressed in kg, and whenever we are taking expressing the kg, okay, so it will be in terms of grams. Okay, so amount of solute in grams present in 100 grams of solute. Okay, so this is our mass percentage. So we'll give you I'll give you example so that you'll be more you'll understand it more quickly. Okay, so if I give you example like 10% glucose solution, 10% glucose solution by mass means what? Means, can you tell me? By using, see here, what do you mean by W by W is mass percentage. Okay, how we have expressed mass percentage? Mass of a solute. Mass of the solute is given as gram. Okay, how the mass is expressed? It is expressed in small w. Okay, we have taken W. Okay, we have taken W. So to express, and total mass of the solution, what is total mass of the solution? That is solute plus solvent. So this is also expressed in terms of grams. Okay, so it is W by W. So it is expressed as W by W. Okay, so can you tell me what do you mean by 10% 10% glucose solution by mass means? 10% glucose solution by mass means? Yes, students? Mass of the solute divided by total mass of the solution. Apply this. If it is wrong also, no problem. You have to try. Okay. From the first class itself, if you try, okay, then you will get that confidence. Okay, you will get that confidence. So never hesitate to try. Okay, never hesitate to try. You have to always try. Yes, nobody? 10% glucose solution. See here, what do you mean by mass percentage, students? Okay, just a second. I'll explain you again. So still, okay. Mass, this mass percentage, okay, it is expressed as W by W. Now, how it is given as mass percent of component, okay, is equal to mass of solute divided by total mass of solution, total mass of solution. Solution means solute plus solvent. Okay. Now, how it is expressed? Mass. Mass. What is the unit of mass? Yes. It is, the smallest unit is grams, right? It is taken as grams. Then total mass of the solution, this is also expressed as grams, okay, into 100. So this is the, what you say? No, 100 ml. ml comes in volume. Okay, when you take milk, okay, when you take milk, it will be some, suppose half liter, okay. So this will means equal to 500 ml, right? So it comes in ml. Understood? Mass. Suppose you go to take sugar. Will the sugar will be in ml? No, it is in kg. Okay. Suppose I want 1 kg. I want 1 kg. 1 kg means 1000. Understood? Yes. Yes, it is 1000 gram like that. Got it? So mass, it is expressed in terms of W. W means you can consider it as weight. Okay, weight by weight. We are considering the weight. Mass. Mass means what? Weight, right? So it is expressed in terms of W by W because both the components are present in grams, right? Total component, total mass of the component in the solution. The component is nothing but your solute and total mass of the solution. So this is the term. So it is given as W by W. Weight is expressed as W by W because we are taking mass. Okay, we are taking the mass of a solute divided by the total mass of the solution. Okay. Now I had given you example. Please come on this now. 10% glucose solution by mass. 10%. How 10% is given? 10 by 100. Right. 10% is nothing but 10 by 100. Right. So when I take 10 grams, so 10 grams of glucose, so I'll take in terms of grams now. So 10 grams of glucose dissolved in, so 100 minus 10 is 90 grams of water. Okay. So this results into 100 grams of the solution. Understood? So 10 divided by 10 plus 90. Okay. So this is the total solution. Understood? Is it clear now? Is it clear? So 10% means 10 by 100. Okay. 10% means 10 by 100. Okay. So 10 grams of glucose. Glucose is what? Our solute. What is the formula? Mass percentage. Mass of solute divided by total mass of solution. Okay. Now, mass of solute is what? 10. Because 10%. So 10 by 100 divided by total mass of solution. So 10 grams dissolved in 90 grams of water is your solution. That is 100. So this is the meaning of that mass percentage. Understood? Okay. So we will be solving the problem. So what we'll do at the end of the chapter, we are going to discuss completely the problems on this particular chapter. Okay, so I'll give you one example so that time it will be clear, and at the last we'll solve completely the problems on that. Okay, now the second, this is volume percentage. Okay, it is expressed as V by V. It is expressed as V by V. Why it is expressed as V by V? So volume percent of a component. Okay, volume percent or percentage of a component is given as volume of a solute divided by total volume of solution into 100. Okay. Now volume of solute. Volume is expressed in terms of ml. Yes, volume is expressed in terms of ml, and total volume of the solution is also expressed in ml. Okay. Now what is the definition of volume percentage? Volume of a solute in ml dissolved in 100 ml of the solution. Yes, I hope you're writing down the things. Okay, if you have, if you're not understanding, you can make some points, short points. Okay, yes. So volume of a solute in ml dissolved in 100 ml of the solution. 100 ml of the solution. So this is your volume percentage. This is your what? Volume percentage. So I'll give you example now for volume percentage. Okay, 10% of ethanol, 10% of ethanol by volume means what? 10% of ethanol by volume means what? See here, volume percentage is what? It is expressed as the V by V. Why it is expressed as V by V? Because volume of solute. Volume is expressing the now when you are discussing about time. Okay. 1 hour means what? 60 minutes. Okay. 1 minute is 60 seconds. So what is the smallest unit? What we consider is the second, right? Same way, when we are considering the volume, we are going to consider the smallest value. That is our ml. We are going to consider the ml. So volume percentage of the component is volume of the solute in ml divided by total volume of the solution into 100. Okay. So now what is 10% of ethanol by volume means? Means what? 10%, 10 by 100. Okay. So 10 ml of ethanol. Okay. 10 ml of ethanol dissolved in okay, in 90 ml of water. Okay, in 90 ml of water. So it will give you the total solution will be, so 10 by 10 plus 90. So the total solution is 100. Is it correct? Yes. Okay, so understood. Is it clear? See, don't get confused. Solution is made up of solute plus solvent. Solute plus solvent. So our solvent is water. So 10 ml of ethanol will be dissolved in 90 ml of water and it will give you 100 ml of solution. So the total solution will be 100. Is it clear? Are these two terms clear? Yes, everybody. So there are 16 participants. Okay. Is it clear, students? Shall we move further, or if you have any doubts, I shall repeat it again. Any doubts still here? So you can ask the doubts anytime. Okay. Don't. Okay. So there are no doubts. Anita has said no doubts. Akshaya, Suraya. Okay, fine. Okay, Amma has also said no doubts. Okay, fine. So whoever is saying no today, okay, no doubts. Tomorrow I'll be asking questions. And if you do not answer, then we will see. Yes? Okay, fine. So these are the important two terms which we have discussed. Okay. So whenever if the examples are clearer, okay, you remember the examples. Okay, so that time your concept will be also more clearer. Okay, next is mass by volume percent. Next is mass by volume percent. Now, what do you mean by mass by volume? Mass. Mass is taken in terms of W, weight, right? Volume is V. So it is W by V. It is expressed as W by V. Now, what is the formula? Okay, what is the formula to express the mass by volume percentage? So mass of the solute divided by total volume of solution in ml. Yes, I'll write it here. Mass of solute divided by total volume of solution in ml. Okay. Now here, mass of the solute will be expressed in terms of grams and volume of the solution in ml into 100. Okay. We are taking percentage. Percentage should also always be expressed in 100. Yes. Percentage should always be expressed in terms of 100. Okay. Next. So here we'll give you a formula now. So this is a formula. Okay, definition of mass by volume percentage. Okay, amount of solute in grams, amount of solute in grams dissolved in 100 ml of solution. Is it? So amount of solute in grams dissolved in 100 ml of solution is your mass by volume percentage. Yes. So this is the formula to express the mass by volume percentage. Okay. So let me give you a example. So 10% of NaCl solution. Yes. Can you tell me? Yes, students, 10% of NaCl solution. How will you express this in terms of mass by volume percentage? How will you express this in terms of mass by volume percentage? 10% of NaCl solution. Okay. Suraya has answered it as 10 grams. Okay. See here, it should be sentence. Okay. What is 10 grams now? 10 grams of solute. What is solute? NaCl. So 10 grams of NaCl dissolved in 100 ml of solution. Yes, 100 ml of solution. Yes, 10 grams of NaCl. So 10 grams of NaCl dissolved in 100 ml of solution. This is mass volume percent. Is it clear? Everybody slept? Yes, there's no response all of a sudden. Okay, can you hear me now? Can you hear me now, students? Clearly? Yes, okay, fine. See here, mass by volume percentage, it is expressed in terms of small w by V. Okay, small w by V. So that is mass is expressed as volume as V. So we are denoting it by small w by V. So mass of the solute divided by total volume of solution in ml. So mass always expresses grams and total volume of solution is expressed as volume means ml. So and percentage means into 100. So 10 grams of NaCl solution means what? 10% of NaCl solution means we are dissolving 10 grams of, okay, we are dissolving 10 grams of solute in 100 ml of solution. Okay, the total solution is 100 ml. So this is the mass by volume percentage. Okay, next is parts per million. Parts per million means ppm. Okay, the short form is, it is parts per million. The short form is ppm. Okay, it is denoted by ppm. Fine. Now what is ppm? It is the number of parts of a components per million parts. Okay, per million means 10 raised to 6 of the solution. So ppm is, it is the number of parts of component per million parts. That is 10 raised to 6 of the solution. Okay. Now ppm, it is the formula parts per minute. Okay, ppm. This parts per minute we use in centrifugal tube. Do you know centrifugal tube in biology? Yes, ppm. It is also called as parts per minute. Yes, but this is using that centrifugal tube. Okay, in centrifugal, how much it will rotate. Okay, so that is counted on that. Okay, but here we are using it as parts per million. Yes, ppm. Okay. Fine. Okay. So how it is expressed? It is expressed as number of parts of solute, number of parts of solute. Okay. Divided by total number of parts of all components of solution into 10 raised to 6. Okay, parts per million means 10 raised to 6. We are considering million. Million is 10 raised to 6. So number of parts of solute divided by total number of parts of all components of solution. Okay. Now here the number of parts of solute which is present in million parts of solution. So this is the definition. Okay, one more time, I'll repeat the definition. Number of parts of solute present in million parts of solution is the definition for ppm. Okay, so parts per million. Okay, now so this can also be expressed as mass to mass or volume to volume and mass to volume. Okay, now suppose I give you example of a liter. Okay, 1 liter. A liter means 1 liter. So a liter of sea water, I'll write it, a liter of sea water. Okay, it weighs, what is the weight? It weighs as 1030 grams and contains about 6 milligram of dissolved oxygen. Express the concentration of O2 in ppm. So like this will be the question for ppm. So how is the formula? So number of ppm of O2. How it is given as mass of dissolved oxygen divided by total mass of solution into 10 raised to 6. Okay. Now, what is our, as we know, the solute is our oxygen. Okay. And it is dissolved in the total mass of the solution we are going to take. Now, what is the mass of dissolved oxygen? What is the mass? It is 6 milligrams. Okay. So 6 into milligrams is 10 raised to 3 grams. Okay. Divided by total mass of solution is, what is the total mass? It is 1030. Okay. Into 10 raised to 6. Okay. Can you find the answer? Can you find the answer? What will be the answer? Just check. A liter of seawater, okay, the total weight is 1030 grams. It contains 6 milligrams of dissolved oxygen. So you have to express the concentration of oxygen in ppm. So mass of dissolved oxygen divided by total mass of solution into 10 raised to 6. So this is the way you're going to yes, what is the answer? Yes, it is 5.8 ppm. Yes, 5.82 ppm. Okay, so this will be the answer. Yes, good. So did you understand about ppm? Parts per million. So one more time, I'll just repeat the definition. Number of parts of solute present in million parts of solution. Is it clear? Parts per million. Is the example clear? Yes, okay, fine. Next will, okay. So any doubt in today's session? Yes, what you have done is, Anita, you have taken, we have converted 6 into 10 raised to minus 3, right? You might have taken that into decimal. So your answer has come in 0.0058. So if you just shift the decimal, okay, so then it will be in terms of, we have converted, see here, one more thing, I'll just tell you. See, whenever we are discussing the problems, okay, now here, what were the unit? Here it was in gram, right? You can see here, it was in gram here. Okay, so this is in gram and this is in milligram, 6 milligram. So we have to see that the unit should be same. So what we have done, we have converted milligram also in gram. So what we have done, we have added 10 raised to minus 3. Okay, when we want to convert grams into milligrams into grams, we have to multiply it by 10 raised to minus 3. Okay, so that it will be in grams. So whenever we are discussing, so we have to see the units also. Okay, all the components are having the same unit. So you have to convert into the gram. So gram will be the, is it clear? Okay, fine. Others, any doubts? So the remaining terms, okay, concentration terms we'll discuss in the next class. Any doubts still here? So we have discussed, so these are the things which we have discussed today. So we have discussed the terms, okay, homogeneous mixture, solvent, what is solute, what are binary solutions, the types of solutions. We have discussed about the gaseous solutions, examples each, then liquid solutions, examples, solute solutions, okay, solid solutions. Then we had discussed about the, then we started for methods of expressing the concentration solution. So today we have seen mass percentage, volume percentage, mass by volume percentage, and parts per million. Okay, so the remaining we will be discussing in the next class. I hope there are no doubts. Okay, fine. So the remaining things we shall discuss in the next class. So I shall end the session here. Thank you.